Alright, number 18. A cannon sits atop of a 12-meter high cliff. So here's my 12-meter high cliff. And the cannon is angled at 30 degrees. And it shoots a cannonball at 22 meters per second. I want to know how long it takes to get up to its maximum height. How long is it in the air total, which is all the way down over here. What is the range of the cannonball? What is its maximum height? And the final resultant velocity. So I got a lot of work to do. Since it's asking me about things about its maximum height, I am going to look at just the part of the motion up to the top. But before I do that, the very, very most important thing is I need to find the components of this initial velocity. The angle in here is 30 degrees, so I know that v naught y is going to be the hypotenuse times the sine of the angle, which will give me 11 meters per second. I know that Vx is going to be the hypotenuse times the cosine of the angle, which gives me 19 meters per second. Now I'm going to work vertically to the top. So I'm looking at just this part of the motion. Vertically, I know the initial speed of the cannonball when it's shot is what I found up there. V naught y is 11 meters per second. I know that the velocity of this thing at the top is 0. I know that its acceleration while it's in there is negative 9.8. And I'm going to look for time and for distance. So we'll do distance first. V squared equals V naught squared plus 2AD. 0 equals 11 squared plus 2 negative 9.8 D. 11 squared is 121. So I'm going to subtract it to the other side. So I have negative 121 equals negative 19.6 D. Divide by 19.6 and I get this distance is 6.17 meters. Now that's the distance just from this launch point up to the top. So the maximum height is going to be whatever that distance is plus the height of the building. So D max is 12 plus that is 18.17 meters. That's the answer to one of the questions. It also wants to know how long it takes the cannonball to get up to its maximum height. So I know that V equals V naught plus AT. 0 equals 11 minus 9.8 T. I'm going to do negative 11 equals negative 9.8 T. Divide by 9.8. And it takes 1.12 seconds. T up to the top, I'll say, is 1.12 seconds. Now it wants to know how long it's in for the air total. In order to do that, I need to look at the time it takes to get back down. I'm going to do that in red. So looking for the time it takes to get back down. To do that, I am going to start from the top and go all the way back down. Starting from the top, I know that V naught is 0. I know that A is negative 9.8. And I just found that it's falling from its maximum height. So the distance it falls is going to be a negative 18.17 meters. And I'm looking for T. So I know that D equals V naught T plus 1/2 AT squared. Negative 18.17 equals 0 minus 4.9. Again, negative 9.8. Half of that is 4.9 T squared. I have 18.17 divided by 4.9. Take the square root of that, and I get, that doesn't make sense, let me try that again. 18.17 divided by 4.9. Take the square root of that number, that's better, and I get 1.9 seconds. We'll put 9.3. So this is the T to the bottom. So the total time that this thing is in the air is going to be the time it takes to get to the top plus the time it takes to get to the bottom. And I get that to be 3.04 seconds. Now that I know the total time in the air, I can look back and find the horizontal distance. I know that the horizontal speed from the top of this was, let me look back up there, horizontal speed was 19 meters per second. So Vx is 19 meters per second. I know that t is 3.04 seconds. So I know that dx equals vxt. So I have 19 times 3.04. And I get, this thing lands a distance of 57.8.9, we'll say, meters away from the base. The last thing I need to do is figure out the final resultant velocity of this thing. So far I know it has a horizontal component of 19, and I need to find its vertical component. So we're going to go back up to this thing on the way down. So we'll use our green thing. On the way down, I know that the velocity at the top was 0. I know that A is negative 9.8. And I know that the distance it fell was whatever that d max was. It's over here, the 18.17. And I'm looking for the velocity. It's the floor width. To do that, I am going to use v squared equals v naught squared, sorry, that's that up there, plus 2ad. V squared equals 0 plus 2 times negative 9.8 times negative 18. Sorry, I can't fit that, so I have 2 times 9.8 times 18.17. Take the square root of that answer, and I get 18.9. So, in the end, to do this final piece, I have a horizontal velocity of 19 meters per second. That stays constant. I have a vertical component that is 18.9 meters per second. To get this resultant, I use the Pythagorean theorem. So I have 18.9 squared plus 19 squared. Take the square root of that, and I get 26.8 meters per second. And again, if I wanted to be totally cool, I could find the angle, which would be the inverse tangent of 18.9 over 19, which is going to be just about 45 degrees, which comes out to be 44.8 degrees. We'll round it to 45 degrees. So at 45 degrees below horizontal.